All right, so today we are going to be looking at 5.1. So starting our last chapter for before our final here, and this one's going to go fairly quickly here. Um, we want to go ahead and we're going to work with inverse equations here. So our learning targets here to solve equations by using the inverse trig functions and to find values of expressions involving trig functions. So basically kind of looking at our inverse sine, inverse cosine, inverse tangent, things like that. So if you wanted to find if the sine of x is equal to 1/2, what is x? Well, again, we could use our inverse sine of 1/2 here, but we want it in radians here. So if I were to do that, x is equal to the inverse sine of 1/2. So I could go ahead now and look here on my unit circle. Remember, sine corresponds with y here, so this is your y value. So there's going to be two of those, so look for what your two y values where they're equal to 1/2. Well, we got one here, and we've got one over here. So what's the angle value? The angle value there is pi over 6 and 5 pi over 6. So again, we can just use our nice unit circle there to figure out our values there. So find that y value. So if sine corresponds with y, then cosine corresponds with your x value in your unit circle. All right, so these are kind of the definitions. Inverse sine, it looks like sine of the -1. It's also called the arc sine. So then we can come down here. We're going to find the values in between 0 and 2 pi because that's going to correspond with what we're going to do later. So including 0 but not including 2 pi because 2 pi and 0 are exactly the same value. They're both here. So we only want one of those. So we'll take the 0 one. So the inverse sine of 1/2 there, we just found that to be, that's how we'd write it. The inverse sine of 1/2 there is pi over 6. So inverse sine, looking at the angle, you get pi over 6. Inverse sine of 1/2 is also equal to 5 pi over 6. So the solution there, just like we had on the first page there, is pi over 6 and 5 pi over 6. This is just another way of kind of thinking through it, just kind of writing it out. So let's look at now the inverse cosine. Like we said, now cosine is our x value on the unit circle. So now we're looking for x value on unit circle. What's it match up with? So again, between 0 and 2 pi, including 0 but not 2 pi. So they want us to go ahead and find what's the inverse cosine of square root of 3 over 2. So let's find it on our unit circle. So my x value is the square root of 3 over 2, and it's also down here. So what are my angles there? They are pi over 6 and 11 pi over 6. So hopefully that makes pretty much sense. Kind of just looking for the angle value given this time the cosine, which is our x value there. So finding those two angles that match. Inverse tangent, again between 0 and 2 pi there. So let's find those. We got 3 pi over 4 and we got 7 pi over 4 is what they're saying that they are. The way that you find tangent, if you remember, you're going to use your identity sheet. So you're going to probably want out your identity sheet as well. And if you look down your tangent column, if you remember how that goes, it's over here at 45 degrees and pi over 4. If you notice how that goes, it corresponds with the positive value on your identity sheet there. So instead of, you're looking at -1 here, so we can look on our identity sheet just for +1. So we're looking at there at 3, we're looking at -1 there, so we got pi over 4 here on the unit circle. So this one is equal to 1, and you can tell tangent is positive. So flip pi over 4 over into quadrant 2 over here, and you get 3 pi over 4, which remember tangent up here is negative, so that's going to give you a -1 value. If you flip 3 pi over 4 down into quadrant 3 down here, you're going to get 5 pi over 4 down here. So down here, tangent is positive, so we want a +1 there. And then if you flip 5 pi over in quadrant 4 here, you get 7 pi over 4. And if you look down here, tangent there's negative, so you get a -1. So you're looking for where tangent is -1, and notice is up here at 3 pi over 4, and it's over here at 7 pi over 4. So our two solutions there are 7 pi, or 3 pi over 4, and 7 pi over 4. So again, use your identity sheet and your unit circle to be able to get those two values. Again, just like with sine and cosine, as well as tangent there, we got two values. So now we're just going to go ahead and find the simple values here. So let's go ahead and find the inverse sine is square root of 3 over 2. Remember, sine is your y value. Where in a unit circle your y value equal to square root of 3 over 2. So I'm looking there and I'm saying, oh, square root of 3 over 2 is there, and square root of 3 over 2 for my y value is there. So those are at pi over 3 and 2 pi over 3. Inverse cosine of negative square root of 3 over 2. Oh, now I'm looking for x value. Where on the unit circle is my x value equal to negative square root of 3 over 2? Oh, x value on the unit circle, negative square root of 3 over 2, and x value on the unit circle, negative square root of 3 over 2. What are those angles? 5 pi over 6 and 7 pi over 6. 5 pi over 6, 7 pi over 6. And then our other one here, we've got inverse cosine there. And then our third one here, the inverse cosine of 4 there, that one gets a little tricky there, just simply because if you remember on the unit circle, if you look over here, you're not going to see where is your x value there equal to 4. If I looked, x value equals 4, not finding it at all. So if you remember, of course, when we did our cosine graphs before and we graphed them out, I want to graph out pi over 2, pi, 3 pi over 2, and 2 pi. Notice your cosine graph here oscillates between 1 and negative 1, so it's never going to equal 4 there. So we can also check on our calculator to make sure that's true. I can go inverse cosine of 4 and hit enter, and I'm going to get an error. And I'm getting an error simply because, again, it's not on the unit circle. The x value is not going to equal, so. So here are some inverse rules here. If you take the sine of the inverse sine of x, you simply get that x. It's kind of undoing itself. Same thing over here in the other direction as well. The inverse sine of the sine of x is equal to x. And we can do the same thing with the cosines. The cosine of the inverse cosine of x is equal to x, and the inverse cosine of the cosine of x is equal to x, provided that, you know, they're actually defined on the unit circle. And the tangent of the inverse tangent of x is equal to x, and the inverse tangent of tangent of x is equal to x. So let's kind of look at some of these. So these, you might want to go ahead and plug them also into your calculator just to double check, but let's do one of those. Let's do the cosine of the inverse cosine. Oops. Let's do that again. Cosine, inverse cosine, 3 divided by 4. And if I hit math fract here, I get 3/4. So the cosine of the inverse cosine of 3/4 is 3/4. We could do the same thing with the tangent of the inverse tangent. Tangent, inverse tangent of 8. We're going to get 8. And the tricky one here, this one's a little tricky here, but we can plug it in there just to see if it exists. So the sine of the inverse sine of pi divided by 4. And you can't hit math frac because it's in pi's here, so you can check to see if it's pi over 4. So I'm guessing it's pi over 4 here. And yep, those two values do indeed equal each other, so pi over 4. So far it's following our rule there that if we take the cosine of the inverse cosine of this value here, we just get that value. Same thing here, tangent of the inverse tangent of 8, we get 8. The sine of the inverse sine of pi over 4, we get pi over 4. So it's almost looking like if we do this next one, that the sine of the inverse sine of 3, that we're going to get 3. But remember, is that one defined on the unit circle? Think about that. So if I do one like that, the sine of the inverse sine of 3. And I'm going to get an error because, again, that one doesn't exist on the unit circle. You can't find that value at 3 because it's only defined between -1 to 1. So now let's look at that inverse cosine, the cosine of negative pi over 3. Inverse cosine. Inverse cosine. Inverse cosine of the cosine of negative pi divided by 3. And I'm getting this value, so it's defined. Is that the negative pi over 3? Yes, they end up matching. So we can say this is negative pi over 3. And then let's go ahead and look at these as well. So this one here, if you remember, the inverse sine there, we're just looking at where the y value is equal to square root of 2 over 2. The y value is equal to square root of 2 over 2 right here at pi over 4. So I'm going to now take the tangent of pi over 4, and looking at your identity sheet, your tangent at pi over 4 there tells you it has a value of 1. So now let's do the next one here. We've got inverse sine of 1/2. Again, looking at the y value. Where is your y value? Equal to 1/2. My y value is equal to 1/2 here at pi over 6. So I've got the cosine of pi over 6. And if you look, what's your x value there at pi over 6? It's the square root of 3 over 2. Alright, so to be continued on the second video here, so let me go ahead and stop this.